Hello, my dear students. Welcome to the third lecture of electrostatic potential and capacitance. In this lecture, we will discuss the MCQ questions of potential energy of a system of charges and potential energy in an external field. So, the first question in this topic is: a test charge is moved from lower potential point to a higher potential point. The potential energy of test charge will. So, here in this particular case, assume there is a positive charge, and due to that positive charge, assume that its field generally moves extend from the charge to infinity. So here in that particular case, assume that there are two locations we will be taking two locations over here. So here this is location A and this is location B. So we also know that if this is a charge Q, then as we move away from the charge, the potential due to the charge decreases. Clear? So assume that here the potential is 20 volt and here the potential is 10 volt. Clear? So when we place a charge at B, suppose a test charge is moved from B to A, that means B is at lower potential, B is at lower potential and A is at higher potential. So here in this particular case, if we move a test charge, let the test charge be Q naught, it is moved from B to A. Clear? Then here in this particular case, whether its potential energy will increase or not. Clear? So that means here in this particular case, what is the initial potential energy which will be at B? It will be simply Q naught into potential at B. Clear? So it will be Q naught into 10. And what will be the potential at A? Potential at A will be equal to Q naught into VA and Q naught into 20. Clear? So that means potential at A we are getting 20 Q naught and potential at B we are getting 10 Q naught. Clear? So that means it is an obvious thing that when we are moving from a region of lower potential to a region of higher potential, the potential energy of the test charge will increase. Here, and how much it has increased? So change in the potential energy is UA minus UB. So 20 Q naught minus 10 Q naught. So it will be 10 Q naught. That means it is coming out to be positive. The change in potential energy is coming out to be positive. That means the potential energy of the test charge will increase. So option B will be the correct one. Next, in question number 33 of MTG fingertips, a system consists of two charges, 4 microcoulomb and minus 3 microcoulomb, with no external field placed at minus 5 centimeter and 5 centimeter respectively. The amount of work required to separate the two charges infinitely away from each other. So here in this particular case, what it is asking that there is a system. Assume that there is a system. So let this be the origin. So there is a charge. There are two charges of 4 microcoulomb. 4 microcoulomb is located at minus 5 centimeter. So over here let it be minus 5 centimeter, and over here let it be plus 5 centimeter. Clear? So 4 microcoulomb is placed at minus 5 centimeter and minus 3 microcoulomb is placed at plus 5 centimeter. The amount of wire required to separate the two charges, that means here in this particular case, separately if we put these two charges, or individually if we put the two charges at infinity, suppose infinity is somewhere located over here, that means charges infinitely away from each other. That means suppose if minus 3 will be at plus infinity and let 4 be will be over there its location. That means in that case how much work is required. So it is same as the wire required to put the two charges having this system. यहाँ पे ये जो क्वेश्चन में बोला गया है कि ये जो मान लो कि ये जो दोनों चार्ज को इन्फाइनाइटली हम सेपरेट करने के लिए कितना वार करना पड़ेगा. अभी तो इनके बीच में डिस्टेंस ऑफ सेपरेशन कितना है, अभी इनके बीच में डिस्टेंस ऑफ सेपरेशन है 10 सेंटीमीटर. इनको हमें इन्फाइनाइटली सेपरेट करना है. क्लियर. तो जब हम उनको इन्फाइनाइटली सेपरेट करेंगे तो उनका पोटेंशियल एनर्जी कितना हो जाएगा, 0 हो जाएगा. क्लियर. तो वार्डन यहाँ पे कितना होगा, सो वार्डन कितना होगा, अगर मान लो कि वो इन्फाइनाइटली सेपरेटेड हैं पहले से ही, तो ये सिस्टम बनाने के लिए कितना वार करना पड़ेगा, तो ये सिस्टम बनाने के लिए कितना वार करना पड़ेगा, जितना उसका पोटेंशियल एनर्जी होगा. क्लियर. तो अगर हम इसका पोटेंशियल एनर्जी यहाँ पे निकाल लेंगे, अभी जो सिस्टम है, जिस कॉन्फ़िगरेशन का जो सिस्टम है, उसका पोटेंशियल एनर्जी जितना होगा उतना ही वार हमें करना पड़ेगा इस सिस्टम को सेपरेट करने के. क्लियर. So here in this particular case, what will be the potential energy of the system? Potential energy of the system will be equal to K Q1 Q2 divided by distance of separation R. Clear? So here in this particular case, if we put all these values which are given over here, so K will be equal to 9 into 10 to the power 9. What is charge Q1? Let this be Q1 and let it be Q2. So Q1 is 4 into 10 to the power minus 6 coulomb into Q2 is minus 3 into 10 to the power minus 6 coulomb, all divided by distance of separation is 10 centimeter, that means 10 into 10 to the power minus 2 meter. So finally it will be calculating this way. So 4 3 is 12, 12 9 is 108, so it will be minus 108 into, here it is 9 and 10 to the minus 12, so 10 to the power minus 3, and here it is 10 to the minus 1, so it will be plus 1 here. So how much will you be getting? We will be getting 10 to the minus 2, so 10 to the minus 2 means minus 1.08. Clear. So this much joule, so minus 1.08. so that means here in this particular case, suppose यहाँ पे अगर हम ऐसे बोलेंगे कि मान लो कि पहले से ही एक चार्ज, मान लो कि there is a 4 microcoulomb charge is located at some location, and at some location, that means suppose this is something like it is extending up to infinity, this is infinity over here. Suppose initially this is origin. Suppose if we take, so here in this particular case this is origin, and suppose this minus 3 microcoulomb charge will be located over at infinity here. Then what will be the potential energy of the system? That means here in this particular case the distance between them is how much? We will consider that one as infinity. If they are infinitely separated, then potential energy of the system will be how much? K Q1 Q2 divided by infinity. So that means this particular value will be 0. That means potential energy at this location will be 0. Then what will be the work done to move this minus 3 microcoulomb charge to this particular location? या फिर यहाँ पे अगर ऐसा पूछा जाएगा कि कितना वार्डन करना पड़ेगा ताकि हम ये 3 माइक्रोकुलम चार्ज को हम ऐसा एक सिस्टम बना सकते हैं, ये वाला सिस्टम जैसा है वैसा सिस्टम बनाने के लिए कितना वार्डन करना पड़ेगा, उतना ही वार्डन, मतलब इतना तो रहेगा 1.08 मैग्नीट्यूड वाइज, बट नेगेटिव साइन विल नॉट बी देयर. क्लियर. यहाँ पे नेगेटिव साइन नहीं होगा. तो अगर हमें ये सिस्टम बनाना है तो उस केस में वार्डन कितना होगा, सिंपली 1.08 जूल का वार्डन होगा, एंड दैट वर्क विल बी डन बाय एक्सटर्नल एजेंट. हियर दिस इज द वार्डन बाय द फील्ड. क्लियर. इन्फाइनाइटली सेपरेट करने के लिए ये किसको काम करना पड़ रहा है, दिस इज द वर्क डन बाय फील्ड. क्लियर. और फील्ड के बेस से जो वर्क होता है वो नेगेटिव होता है. क्लियर. okay, so this is, so that means here minus 1.08, that means we'll check 1.08 means obviously equal to minus 1.1 joule. So option A will be the correct one. Next, in question number 34, two charges of magnitude 5 nanocoulomb and minus 2 nanocoulomb, one placed at 2 centimeter and x centimeter in a region of space. where there is no other external field. Clear? So this only, that means in a space there are only two charges, no external field is there. Clear? So two charges is, one is 5 nanocoulomb and another is minus 2 nanocoulomb, and they are placed one after another. That means first one is placed at plus 2 centimeter and another one is placed at plus x centimeter, that means along the positive x direction. Clear? If the electrostatic potential energy of the system is given, then the value of x is, it is asking. So potential energy of the system is minus 0.5 microjoule. Okay, and here in this particular case, what other informations are given? To charges, let it be q1 equal to 5 nanocoulomb, that means 5 into 10 to the power minus 9 coulomb, and another charge q2, let it be minus 2 nanocoulomb, so minus 2 into 10 to the power minus 9 coulomb. So if I draw the figure of this one, so let this be the origin over here, and here along the positive x direction, let it be 2 centimeter, and over here anywhere else let it be x centimeter. Clear? So 5 nanocoulomb is placed over here and minus 2 nanocoulomb is placed over here. So what is the potential energy of this system? So we know that the formula for potential, and okay, potential energy is given, is asking to find out the value of x. Clear? So we know that u equal to k q1 q2 by distance of separation, let it be r. Clear? So what is the value of this particular distance here? So this one is, so here is 2 centimeter, this is x centimeter, that means this value will be x minus centimeter. Clear? So finally, if we will substitute all these values, so here in this particular case, the value of u is given minus that is minus 0.5 microjoule, that means minus 0.5 into 10 to the power minus 6 joule. So minus 0.5 into 10 to the power minus 6 equal to k is 9 into 10 to the power 9 q1. q1 is 5 into 10 to the power minus 9. q2 is minus 2 into 10 to the power minus 9 whole divided by distance of separation, let that one will be x minus 2. Clear? Distance of separation, that will be x minus 2, but that is in centimeter, so we have to convert that one into meter, so it will be 10 to the minus 2. Okay, so from here we do the calculation. We want to find out the value of x, so let x minus 2 be in the left hand side, so that one will be, so here 10 to the 9, 10 to the minus 9 will get cancelled out, and here, so how much left? So we do further calculation. So 10 to the minus 2, if it goes to the numerator, so it will be 10 to the minus 7. So 9, so minus 9 into 2 into 10 to the power minus 7 all divided by minus 0.5 into 10 to the power minus 6. So that we will get, so it will be, so negative both will cancel out, so it will be coming out to be so 9 18, so here it will be 18 into 10 to the minus 6. If it goes up, so it will be 10 to the power minus 1 and divided by 0.5. 0.5 means it will be, let it be 1 by 2. I think we are forgetting something else. Here it is 5. Okay, important to write 5. So here 9 minus 2, here 5 should be there. Clear? So here it should be into 5. So finally but here it is 90, it is 90, 19 to 2 divided by 10, divided by 10 here. So x minus 2 is 18, that implies the value of x will be 20. Clear? So finally how much we got? We get the value of x will be how much? It will be 20. Clear? So 20 centimeter. Okay, so fine. So here option A will be the correct one. Okay, next in question number 35. In a quark model of elementary particles, a neutron is made of one up quark. There is one up quark of charge plus 2 by 3 and two down quarks of charge minus 1 by 3. Okay, that means here up quark, if it is indicated by u, and that value is plus 2 by 3 e, and down quark is minus 1 by 3 e. That means when we say there is a neutron that is made up of some quarks. Clear? Neutron is made up of quarks, and means how many quarks we need? We need 3 quarks. One is up quark plus 2 down quark. Clear? So that will give how much? So that will give us up quark is 2 by 3 plus minus 1 by 3, 2 by 3 e, minus 1 by 3 plus minus 1 by 3 e. So that means will whole cancel out. So that means overall charge will be 0. Clear? So that's why the neutron is assumed to be having no charge. That means overall it is neutral. If they have a triangle configuration with side of length of the order 10 to the minus 15 meter, the electrostatic potential energy of neutron in million electron volt or mega electron volt is. So it is asking the potential energy of the neutron. So here what they are saying, quarks or these three quarks are a vertex of here, vertex of an let it so here in this particular case assume that this is the up quark, up quark. That means here it is plus 2 by 3. Here it is one down quark, that is minus 1 by 3. Here there is other down quark minus 1 by 3, and the distance of separation let it be x. Clear? So here in this particular case, if it is x, then know that the value of x, or let it be a or something else you can take. So value of x is given 10 to the minus 15 meter. So here it is a here. So assume that here this is a up quark, this is what, this is a up quark, this is a down quark, this is a down quark of given charges are plus down quark of charge is minus 1 by 3 and up quark is of charge plus 2 by 3. Clear? So what is the potential energy of the system? Then potential energy of the system, how will you calculate the potential energy? So u, total potential energy, will be equal to sum of individual potential energies of the system of two charges. That means कोई भी आप सिस्टम मतलब दो चार्ज वाला सिस्टम को लोगे तो उससे हमें क्या मिलेगा, उनको अगर हम सम करेंगे तो हमें टोटल पोटेंशियल एनर्जी कैसे निकालेंगे, इसका प्रोसेस क्या है? तो पहले जो अगर हम देखेंगे तो ये अप क्वार्क एंड डाउन क्वार्क, ये जो इस साइड में प्रेजेंट है, इनका पोटेंशियल एनर्जी कितना होगा? सो इनका पोटेंशियल एनर्जी हम ऐसे लिख सकते हैं। अब मान लो कि इसको हम अप क्वार्क डाउन क्वार्क के फॉर्मेट में आप ले सकते हो, या फिर ओके ऐसे भी ले सकते हैं। तो इट विल बी ए, अच्छा फॉर्मूला वाइज अगर हम देखेंगे, इसको ज़्यादा कन्फ्यूजन हम नहीं करेंगे। तो लेट इस पर्टिकुलर चार्ज जो यहाँ पे अप क्वार्क है उसको हम Q1 से इंडिकेट कर रहे हैं, जो डाउन क्वार्क है उसको हम Q2 से इंडिकेट करेंगे, और ये जो डाउन क्वार्क है इसको हम Q3 से इंडिकेट करेंगे। ठीक है, तो ये ऐसा सिस्टम है। तो Q1 एंड Q2 जो चार्ज यहाँ पे प्रेजेंट है, एंड डिस्टेंस ऑफ सेपरेशन बिटवीन देम इज x, देन पोटेंशियल एनर्जी ऑफ द सिस्टम इज K Q1 Q2 डिवाइडेड बाय x। क्लियर। एंड सिमिलरली Q1 जो अप क्वार्क है वो एक दूसरा डाउन क्वार्क यहाँ पे इसके साथ कनेक्टेड है, जो Q3 के साथ कनेक्टेड है। दैट मीन्स पोटेंशियल एनर्जी ऑफ दैट सिस्टम विल बी K Q1 Q3 डिवाइडेड बाय x प्लस। अभी नीचे अगर हम देखेंगे बॉटम पे, तो बेस पे जो चार्जेस यहाँ पे दो डाउन क्वार्क प्रेजेंट है। क्लियर। तो दो डाउन क्वार्क के बीच में जो पोटेंशियल एनर्जी होगा वो कितना होगा, K Q2 Q3 डिवाइडेड बाय x। क्लियर। तो ये हुआ। तो इसका मतलब है टोटल पोटेंशियल एनर्जी जो है वो कैसे हम लिख सकते हैं, तो एक अप क्वार्क एक डाउन क्वार्क डिवाइडेड बाय x। क्लियर। प्लस K अप क्वार्क डाउन क्वार्क डिवाइडेड बाय x प्लस K, यहाँ पे नीचे दो डाउन क्वार्क है, डाउन क्वार्क डिवाइडेड बाय x। क्लियर। तो ऐसा हम इसको कर सकते हैं। सो दिस इज हाउ वी कैन गेट द पोटेंशियल एनर्जी। तो इसमें अगर हम देखेंगे इस वाले पर्टिकुलर केस में, तो यहाँ पे हम मान लो कि K बाय x को यहाँ पे हम कॉमन लेते हैं, तो हमें कितना मिलेगा, अप क्वार्क डाउन क्वार्क प्लस अप क्वार्क डाउन क्वार्क प्लस 2 डाउन क्वार्क। क्लियर। सो फाइनली ओवर हियर, तो अगर हम इसमें वैल्यूज सब यहाँ पे पुट कर लेंगे, ठीक, ये सभी वैल्यूज अगर हम यहाँ पे डाल देंगे, तो ये कितना होगा, K का वैल्यू है 9 इन 10⁹ डिस्टेंस ऑफ सेपरेशन इज गिवन हाउ मच, इट इज गिवन 10⁻15 मीटर, सो इट इज 10⁻15। अप क्वार्क इज प्लस 2, यहाँ पे आप देख सकते हो अप क्वार्क प्लस 2/3 है, डाउन क्वार्क यहाँ पे -1/3 है। तो अप क्वार्क इज प्लस 2/3 एंड डाउन क्वार्क कितना है, -1/3 प्लस अप क्वार्क है +2/3 एंड डाउन क्वार्क कितना है, -1/3। तो इसको हम दो बार सेपरेट लिखने की कोई ज़रूरत नहीं, बस न्यूमेरिकल कैलकुलेशन कैसा हो रहा है, हम कैसे लिख रहे हैं, प्रोसेस यहाँ पे हम शो कर रहे हैं। क्लियर। नहीं तो आप डायरेक्टली इसको 2 UD करके यहाँ पे इसको D² कर सकते हो, यू विल गेट द आंसर। तो बस प्रोसेस हम देख रहे हैं कि कैसा हो रहा है। क्लियर। तो डाउन क्वार्क यहाँ पे कितना है, -1/3 इंटू -1/3। क्लियर। अच्छा, तो फाइनली अभी कैलकुलेशन हमें करना है। तो E यहाँ पे क्या है, E इज द चार्ज ऑफ एन इलेक्ट्रॉन। क्लियर। तो जो जिसका वैल्यू कितना है, -1.6 इंटू 10⁻19। क्लियर। तो हियर इन दिस पर्टिकुलर केस, so it will be 9 into 10⁻9, that is, if 10⁻15 goes to the numerator, so it will be 9 into 10⁻24. Clear. So here it will be 2/3 into 1/3, so 2/3 into 1/3 it will be equal to 2/9, and E into E it will be E². Clear. Plus here, okay, here it will be minus, as negative sign is there, plus here it will be same 2/9 minus 2/9 into E², and here minus it will be plus, so it will be 1/9 E². Clear. So this is the case. Okay, fine. So further calculations, so it will be 9 into 10⁻24, so it will be how much, it will be 1. So if I take E² outside, will be E² outside, so it will be 1/4 minus 2/9 minus 2/9, so 2/9 plus 2/9 will be 4/9. So finally how much will be getting, so 9 into 10⁻24, and the value of E is 1.6 into 10⁻19, that's square. So it will be 1/4 minus 2/9 minus 2/9, so it will be minus 4/9. Okay, it is 1/9, it is 1/9, it is 1/9 minus 4/9. Okay, and here it will be, so if we do 9 into 10 to the power 24 to 1.6 into 1.6 into 10 to the power, here it will be minus 38, 10 to minus 38, and 1 by 9 minus 4 by 9, 9, so by 9, so minus, clear. So if it is minus 1 by 3, then 3 is a 9, so finally how much we will get? So it will be 3 into 1.6 to 1.6, and negative sign is already there, so we have to keep the negative sign over there, clear. So finally into 10 to the power minus 38 plus 24, clear. So here how much we'll be getting? So we'll be getting so 16 16 so 16 16 ja it will be 16 16 ja, so 6 256, so it will be minus 3 into 2.56 into 10 to the power minus 14. So here it will be let it be like this, let it be like this, clear. So this much joule. Okay, over here, so the potential energy, how much we got? We got the potential energy to be if we do the further calculation, so it will be 3 6 18 6 7, so 7.68 minus 7.68 into 10 to the minus 14 joule. Okay, if it is asked in terms of joule, then potential energy will be this one, clear. But here it is given, it is asked in MeV, billion electron volt. That means we have to convert that one into EV. So we know that 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule, clear. So if is the case, then means 1.6 into 10 to the power minus 19 joule equal to 1 eV. That we need to know. That means 1 joule will be equal to 1 by 1.6 into 10 to the power minus 19 electron volt, and we want to calculate this value. So that means here minus 7.68 into 10 to the power minus 14 joule will be how much, clear. So that will be equal to minus 7.68 into 10 to the power minus 14 divided by 1.6 into 10 to the power minus 19, this much EV. So always remember one thing, if if the energy is given in terms of joule, then divide it by 1.6 into 10 to the minus 19, so that will give you the energy in terms of electron volt, clear. So that this is the direct process, but here I am doing how we can get step by step. So here it will be 16. So here if we know, if we just see, so 3, so 1.6 will cut, clear. So here it will be 3, so 3 into 1.6, so it will be 4.8. so here it will be minus 4.8 minus 4.8, and here this particular value will be, if 19 goes up, then it will be 10 to the 5. That means u will comes out to be minus 4.8 into 10 to the power 5 EV. अगर EV में कुछ आंसर पूछा गया है तो EV में इतना आंसर होगा, लेकिन यहाँ पे मिलियन इलेक्ट्रॉन वोल्ट्स में पूछा गया, सो इट विल बी माइनस 4.8. अच्छा, यहाँ पे मिलियन मीन्स 10 to the 6 होना चाहिए, तो 10 to the 6 कैसे होगा? तो ऊपर में 10 नीचे 10, हम ऊपर में 10 मल्टीप्लाई करें, नीचे 10 डिवाइड, सो डिवाइडेड बाई 10 इंटू 10 to the power 6, so it will be minus 0.48 into 10 to the 6, that means it will be MeV. So minus 0.48 will be the answer. So minus 0.48 minus 0.48, here option C is the correct one. Next we'll discuss the MCQ questions of potential energy in an external field. Okay, here in this particular case, which among the following statement is true about the work done in bringing a unit positive charge, work done in bringing a unit positive charge from point P to Q. From point P is over here and Q is over here in an electrostatic field. That means this is a these 2 points are present in an electrostatic field. So which of the following statement is true? Minimum work is done in case of path 2. So in case of path 2, that means as it is the shortest path. Clear? So here let it be the distance covered be x1 and here x2 and here it is x3. That means we can say x2 is less than rest others. यहाँ पे x1 या फिर x2, x3 से x2 is less than x1 and x2 is also less than x. So path is shortest. That means here it is saying is that work done will be minimum in path 2. Okay. सेकेंड मैक्सिमम वर्क इज डन इन केस ऑफ पाथ 1. पाथ 1 यहाँ पे जैसे लग रहा है कि शायद पाथ 1 में डिस्टेंस कवर सबसे ज़्यादा होगा, तो उसमें सबसे ज़्यादा वर्क हुआ होगा क्योंकि हमारा वर्क डन का जो फॉर्मूला है फोर्स इनटू डिस्प्लेसमेंट है. क्लियर? हियर इट इज डिस्प्लेसमेंट, लेकिन ये डिस्टेंस कवर को यहाँ पे ले रहा है. क्लियर? तो थर्ड केस वर्क डन इज सेम इन ऑल द 3 पाथ्स. क्लियर? Work done is same in all the 3 paths. That means work done while moving in path 1 will be same as in path 2 will be same as in path 3. ये तीनों केस में work done हमारा सेम होगा. Clear? And fourth one, work done is 0 in path 2. Work done will be 0 in path 2. That will be obviously wrong. Why? Because some displacement is there, some force will be acting upon the system, so work done will not be 0 over there. Clear? So this will be wrong, and rest other 2 A and B are also wrong. Why? Because option C is the correct one. And what option C is saying is that work done is same in all the 3 paths. So why it is the case? Why it is the case? Because here we know that electric field is a conservative force field. Electric field is a conservative force field, just like the gravitational field. Clear? So electric field is a conservative force field, just like the gravitational field. That means work done in moving a charge in any kind or any type of conservative force field. Conservative force field is independent of paths. Is independent of the nature of path. Clear? Is independent of the nature path. Independent of nature path, that does not mean that here we will be taking the displacement to be 0. Clear? So यहाँ पे distance cover को हम 0 लेंगे, that is not. Clear? So independent of nature of path, उसका मतलब ये है कि हमें यहाँ पे we need to take the shortest path. We need to take the shortest path between the initial and final position. Between the initial and final position, तो हमें shortest path वहाँ पे लेना है. क्लियर? तो इस वाले पाथ में तो कोई भी आप पाथ ले लो बिटवीन P एंड Q के बीच में हम कोई भी आप पाथ ले लें, लेकिन फाइनली हमें जब वर्क डन हम कैलकुलेट करेंगे तो हमें यही शॉर्टेस्ट पाथ लेना है. तो पाथ 1 का भी शॉर्टेस्ट पाथ ये 2 होगा, पाथ 3 का भी शॉर्टेस्ट पाथ ये 2 ही होगा. क्लियर? तो फाइनली वर्क डन विल बी सेम इन ऑल द 3 पाथ्स. ये ऑप्शन सी सही होगा. Okay, moving to question number 37. An electric dipole of dipole moment P is placed in a uniform electric field E. First, that means they have given some statements. The torque on dipole is P cross E. The potential energy of the system is P dot E. The resultant force on the dipole is 0. So here they are saying choose the correct option. So all are correct. 1 3 are correct, only one correct, 1 and 2 correct, and the rest are wrong. So that means here assume this. That means what is the torque on it acting on a dipole when it is placed in a external electric field, external uniform electric field? Clear? So suppose here in this particular case we'll try to draw a uniform electric field. Suppose these are uniform electric fields. Here, so suppose this is a uniform electric field, and here in this particular case, suppose here there is a dipole. Suppose this is a dipole that is placed in a uniform electric field. Dipole, that means here this is a negative charge, here it is a negative charge, and there is a positive charge plus q present over here. So if it is external uniform electric field, then what is the force acting on the dipole? So electric field is towards right. Yeah, that means force on the positive charge will be towards right. So the what will the force on the dipole? It will be QE plus QE, and force on the negative charge, it will be minus QE. That means negative charge. That means the field will try to move the negative charge in the opposite direction of field. Clear? So that's why force is directed towards left. So then here in this particular case, what is the resultant force? Clear? नेट रिजल्टेंट फोर्स. क्लियर? ये वाला जो है रिजल्टेंट फोर्स एफ नेट इक्वल टू प्लस क्यू ई प्लस माइनस क्यू ई. Clear? So that means these two will cancel out, net force will become 0. So that means option 3, that means here statement 3 is correct. Clear? Net resultant force on the dipole at any position will be 0. Second case, what is the torque acting on the dipole? So in order to find out the torque, we need to find out the perpendicular distance between the given forces here. So perpendicular distance between the given forces, and we need to find out this distance. This is the perpendicular distance between the given forces here. So here in this particular case, if the length of the dipole is 2a, then this length will be 2a cos theta if the dipole makes some angle theta with the uniform electric field. Here assume that the dipole is making some angle theta with the field. Then in this particular case, this side will be 2a cos theta and this side will be 2a sin theta. Clear? Okay. So then the torque, what is the value of torque? The torque over here, tau, will be equal to either of the force into perpendicular distance between the force. So either of the force, that is simply we can write QE into perpendicular distance, that is 2a sin theta. So it will be Q into 2a all into E sin theta. So it will be Q into 2a is nothing but P into E into sin theta. So this is the magnitude of torque, but as torque is a vector quantity, so it will be sin theta some direction, it will be having some direction. That means it will be having the direction perpendicular to the component, perpendicular to both P and E. So here in this particular case, this will be P cross. So torque acting on the dipole is P cross E. That means here it is first statement is also correct. Next, potential energy of the system. Potential energy of the system P. So here in this particular case, what is the potential energy of the system? Assume that the dipole is present in the same uniform electric field. Then what they are saying is that potential energy, how the energy will be stored in a dipole in terms of potential energy, or how you get the potential energy. So work done rotating the dipole is stored as potential energy in the dipole. So who will rotate the dipole? Here if you place the dipole in an external field, then the field will rotate the dipole. Clear? So suppose how will it rotate it? So it will that means the external field will apply a torque upon the dipole. Clear? So work done will be nothing but tau d theta. Clear? So this is how we calculate the work done. Clear? So that means the net work done will be how much? Integral dw. Clear? So it will be tau d theta. Clear? So here in this particular case, tau, what we got right now, it is nothing but pe magnitude wise, pe sine theta and d theta. Clear? So now what will be the limits? So limits will take from theta 1 to theta 2, from any particular angle theta 1 to another particular angle theta 2. Then work done will be equal to p, dipole moment is constant, electric field is uniform, that is also constant, we can take it outside. So simply integral sine theta d theta from theta 1 to theta 2. So it will be pe sine theta, integration is minus cos theta, that means minus cos theta from theta 1 to theta 2. Clear? So what will be getting? So pe minus cos theta 2 minus cos theta 1. Clear? So it will be cos of theta 1 minus cos of theta 2. This is the general formula. Clear? This is the general formula. That means this will be stored as potential energy in the dipole. This is the work done to rotate the dipole. But here in this particular case, generally while finding out the potential energy of a dipole system when it is placed in an uniform field, then in that case what we generally do is that we take the uniform field like this. Suppose this is the uniform field, and assume that there is a dipole which is present over there. Here in this particular case, suppose initially the dipole is present like this. Here this is the initial dipole, and after some time we found the dipole to be making some angle theta. Here this is the final position. Here this is the final position. Clear? So that means finally over here it is making some angle theta, but initially the angle is 90 degree. Clear? So that means initially theta 1 is 90 degree and theta 2 let it be theta. Clear? That means this work done will be nothing but pe cos 90. Cos theta 1 means cos 90 minus cos of theta. So finally cos 90 is 0. So we will be getting pe minus pe cos theta. That means it is minus p bar dot e bar. So that means potential energy of the dipole will be minus p dot e. Clear? So here it should be negative p dot e. It is not positive. Clear? So option statement 2 is wrong. So here 1 and 3 are correct. 1 and 3 are correct. So option here B, 1 and 2 is wrong. So this is, so second statement is wrong. So we'll choose option B. Next, in question number 38, a molecule of a substance has a permanent electric dipole moment. There is a molecule. Suppose there is a substance, maybe any kind of substance, and in that particular substance, there is a molecule which has an electric dipole moment that has a dipole moment of 10 to the power minus 30 coulomb meter. A mole of this substance, suppose we are taking 1 mole of substance, and out of 1 mole of substance, only one molecule has a dipole moment of this one. Clear? So n is 1 mole. That means we know that 1 mole of substance contain how many number of molecules? We generally know that 1 mole of a substance contain how many? So 6.023 Avogadro's number, 6.023 into 10 to the 23 molecules. Clear? So if it is the case, then what is the dipole moment of all the molecules? So dipole moment of 1 mole, you can say 1 mole substance, that means, or you can say dipole moment of all all the substance. That means 6.023 into 10 to the power 23 molecules will be how much? It will be simply equal to 6.023 into 10 to the power 23 into dipole moment of single one, that is 10 to the power minus 30. So that value will be approximately, so dipole moment will be 6.023 into 10 to the power minus 7. Clear? 10 to the power minus 7 coulometer. Okay, this is the dipole moment of the given substance. Clear? Okay, so if it is the case, then a mole of the substance is polarized by applying a strong electrostatic field of magnitude 10 to the power 7 volt per meter. So here in this particular case, electric field is given 10 to the power 7 volt per meter. The direction of field is changed by an angle 60 degrees. So theta over here is 60 degree. Here, so here in this particular case, what they are saying is that initially suppose this is the substance, and it has some dipoles, like this. Clear? It has some okay, just think that the system is something like this. That means uniform electric field is there. These are the fields, and within that field this substance is present, and the dipoles are also aligned themselves along the direction of the field. These are the dipoles. That means Avogadro's number of dipoles are present inside the substance, because we have taken 1 mole of the substance. Clear? All these dipoles are aligned themselves along the direction of field. But after some time, what they are saying is that they are changing the direction of field. That means if we take the same substance, just wait. Here we have taken the same substance, but we are changing the direction of field. Clear? The field direction is right now, we are changing it like this. Here the field. That means here in this particular case, what they are doing is, they are saying is that that means the field is making some angle with how much degree? This field is making right now some angle of 60 degree with the dipole. Here, so if it is making some angle 60 degree with the dipole, then what will happen? Finally, the direction of field is changed by angle 60 degree. The heat released by the substance in aligning the dipole along the new field direction. That means due to that field, what will happen? It will try to orient the dipole along the direction of field. Clear? यहाँ पे क्या होगा? ये torque यहाँ पे add करेगा. Clear? And what the torque will do? The torque will try to orient the dipole along the direction of field. That means it will try to change the direction of the dipole from here. ये जो direction था पहले, उसको इस तरफ change करेगा. Clear? ये वाला angle. Clear? तो उसमें ये जो रोटेशन यहाँ पे होगा, रोटेशन मान लो कि यहाँ पे जो हो रहा है, क्लियर, तो ये रोटेशन के वजह से क्या होगा? सो न्यू डायरेक्शन तो आएगा, उसके साथ साथ सम हीट विल बी रिलीज. तो कितना हीट वहाँ पे रिलीज होगा? तो जितना वर्क होगा उतना अमाउंट का हीट रिलीज होगा. क्लियर? तो हियर इन दिस पर्टिकुलर केस, तो अच्छा, पहले वाला केस, जो ये वाला जो सिस्टम था, हियर इन दिस पर्टिकुलर सिस्टम, what is the potential energy of the dipole? Potential energy of the dipole will be, let it be initial potential energy. So initial potential energy will be minus P dot E. Clear? That means over here, what is the value of P? The value of P for 1 mole of substance, we know that it is 6.023 into 10 to the power minus 7 into E is given 10 to the power 7, and here it is here in this particular case, the theta is how much? Here theta equal to 0 degree. Clear? If theta is equal to 0, that means it will be cos 0. Clear? So finally, how much we will get? 10 to the minus 7, 10 to the plus 7, it will cancel out. Cos 0 is 1, so it will be 6.0 minus, it will be my negative 6.023 joule. Clear? So initial potential energy of the system is negative 6.03 joule. Clear? Similarly, when the dipole, when the field is making an angle, of 60 degree at the time, what is the potential energy of the system? So potential energy of the system, that means minus P dot E. Clear? So here theta should be equal to 60 degree. That means this another case. Clear? So here minus dipole moment, it will be minus PE cos 60 degree. Clear? So minus P is how much? 6.023 into 10 to the power minus 7. E is 10 to the power 7 into cos 60. Cos 60 is 1 by 2. Clear? So it will be these two will cancel out. So it will be minus 6.023 divided by 2 joule. Clear? So finally over here, what is the change in potential energy of the system? So change in potential energy of the system, so delta u is equal to how much? Change in potential energy, that means or you can say here in this particular case, what is the work done? Clear? तो अभी ये जो सिस्टम है, इनिशियल सिस्टम में तो ऐसा था, और फाइनल सिस्टम में क्या हुआ, हम सडनली क्या हुआ कि हम फील्ड को चेंज करें, तो फील्ड को चेंज करने के टाइम पे ही उसका पोटेंशियल एनर्जी इतना हमें मिला, तो वो फील्ड चेंज होने के बाद तो फिर ओरिएंटेशन होगा। क्लियर? तो वो ओरिएंटेशन जो होगा उसमें कितना वर्क डन होगा, दैट वर्क डन विल बी नथिंग बट चेंज इन पोटेंशियल एनर्जी ऑफ द सिस्टम। क्लियर? दैट वर्क डन इज वर्क डन बाय द फील्ड। यहाँ पे कौन काम कर रहा है? फील्ड ही तो काम करेगा ना, वहाँ पे डाइपोल का ओरिएंटेशन फाइनली होगा। क्लियर? तो दैट वर्क डन बाय द फील्ड, हियर आई एम राइटिंग वर्क डन बाय द फील्ड equal to negative of change in potential energy of the system. So that means negative of u final minus u initial. So that will be u initial minus u final. Clear? So negative of change in potential energy will be, it's generally written like this. So here what is u initial? U initial is minus 6.023 minus u final is minus, that means it will be so it will be plus 6.023 divided by 2, this much. Clear? So finally in this particular case, how much we'll be getting? We'll be getting approximately, so if I take approximately 6, so 6 minus 6 by 2, so it will generally it will be coming out to minus 3. Clear? So here if it is so that means here if I take so that means it will be negative 0.02. Why? Because if I take 6.023 come outside, then 1 by 2 minus 1, so it will be minus 1 by 2, so it will be having the value minus 3.01 something, that means approximately 3. So what done is this, so this much amount of heat energy will be released, so approximately minus 3 joules. So here minus 3 is given, so minus 3, so heat released by the substance in aligning the dipole along the new direction, it will be minus 3 joules, approximately minus 3 joules of heat will be released. So option B is the correct one. Okay, here in question number 39, an electric dipole of length 20 centimeter having charges 3 into 10 to minus 3 coulomb placed at 60 degree with respect to a uniform electric field experience a torque is given 6 newton meter. The potential energy of the dipole is, okay, fine. So here in this particular case, here what they're saying is that there is a uniform electric field which is present. This is the uniform electric fields. Assume these are all uniform electric fields directed towards x, and there is a dipole which is present over here. Suppose this is the dipole. Here, if it is the dipole, and how much angle it makes? It makes an angle of 60 degree. Clear? So here if it is the case, then assume that this is a negative charge, that means minus 3 into 10 to the power minus 3 coulomb, and here it is positive 3 into 10 to the power minus coulomb of positive charge, and distance of separation between them is 20 centimeters. Here distance between the two charges is 20 centimeter. Okay, and due to that field, what it happens, it will experience a torque. The direction of torque will be clockwise. Clear? So here in this particular case, so the value of torque, if we will write tau, value of torque is tau is equal to P E sin theta. Magnitude wise it will be simply P sin theta. Clear? So the value of torque is given 6 Newton meter. So here we can write 6 will be equal to dipole moment. Dipole moment we need to find out. So dipole moment will be Q into 2A. So Q is 3 into 10 to the power minus 3 into 2A is 20 into 10 to the power minus 2. So it will be 60 into 10 to the power minus 5, or 6 into 10 to the power minus 4 coulomb meter. So dipole moment is how much? 6 into 10 to the minus 4. Electric field we don't know, that we will first calculate. After that we can get the potential energy. So but torque is given 6 Newton meter. So 6 equal to P is 6 into 10 to the power minus 4 E, and theta over here is 60 degree. Clear? So P E sin 60 is root 3 by 2. Clear? So the value of E from here, how much we'll get? So 6 will cancel out. Clear? So obviously this value will be, E will be equal to we'll be getting 2 divided by 2 divided by root 3 into 10 to the power minus 4. So finally it will be electric field will be equal to 2 into 10 to the power 4 divided by root 3. Clear? So this much electric field will get. Okay, if this is the electric field we are getting, then potential energy of the dipole. So potential energy, so what is the potential energy of the dipole over that particular case? So we know that the formula for potential energy is minus P dot E. The potential energy is minus P dot E. So it will be minus PE cos theta. So here P, how much we got? P is 6, negative 6 into 10 to the power minus 4. Here, and the value of E just we got 2 into 10 to the power 4 divided by root 3, and cos theta, that means cos of 60 degree cos. So finally how much we'll get? So here in this particular case, so if we take calculation, cos 60 is it is 1 by 2. Clear? So cos 60 is 1 by 2. That means here how much we'll get? So potential energy, we'll check it. So here so it is 1 by 2. So let us write it. So 10 to the power minus 4, 10 to the power plus 4 will get cancel out. So minus 6 into 2 divided by root 3. Here, so here 2 got cancelled out. So minus 6 by root 3, minus 6, so that means minus 2 into 3 divided by root 3. So it will be minus 2 root 3. So finally minus 2 root 3 joules. Clear? So potential energy will be getting minus 2 root 3 joules. Minus 2 root 3. So option A, we are getting minus 2 root 3. So that will be the correct one. Rest are wrong.